So now that we have the unit running, it is very important to look at what the hypercell is doing on amperage and voltage. So the set point for amperage is 123 and my maximum voltage on my hypercell is 24 volts. Now we expect this unit to run at about 20 volts and that depends on the amount of salt going in, which is always a bit different in starting. 123 amp is equivalent to the amount of chlorine that you are producing. Therefore, this number is very important. So let this unit run for at least a half an hour to see if this amperage and voltage is settling down on its set point. If this is reaching set point and we are happy with these values, then let this unit run for at least 2 hours, and then we're gonna take a sample from the product to measure free available chlorine and maybe a pH check. During production, the temperature inside this electrical cabinet will rise because of the heat generated by the power supplies. There is a temperature probe installed just behind the power supplies that is measuring the temperature of the electrical cabinet. At 95 degrees Fahrenheit, the cooling fan will start and it will try to keep that at 95 or below. It will control up to 100% to maintain that 95 degrees Fahrenheit. If this temperature inside the electrical cabinet rises above 125, it will generate an alarm. We also have a temperature sensor inside incoming water line, and we have a temperature sensor on the outgoing water line or in the oxidant line. At the moment, these temperatures are matching. During production, you will see that there is between 15 and 20 degrees difference between the outlet and the inlet. So we also measure a difference in that temperature. The temperature inlet cannot be below 40 degrees Fahrenheit. Below that temperature, salt will not saturate in water anymore. Our maximum temperature outlet is 120 degrees Fahrenheit. So there can be a difference between the inlet and the outlet. And we expect a difference of maybe 15 degrees because of the production. So we have a minimum and we have a maximum expected temperature difference. The minimum is at least 5 degrees. The maximum is about 25 to 30 degrees Fahrenheit. If the inlet temperature is too warm, we would expect that the outlet temperature would be too hot as well. That's why there is a maximum inlet temperature of 80 degrees Fahrenheit. These alarms generated by the temperature will reset themselves when the temperature has decreased under its limit. Our oxidant is filling the degasser tank, and we see that we have a level inside the degasser tank of 3.9 inches. Our booster pump at the moment is controlled at 82%, and our outgoing flow is 0.67 gallons a minute. The control of the booster pump is increasing or decreasing to maintain a level in the degasser tank. It'll start when it's above 4 inches. It'll stop when it's below 3 inches. But the amount of the control is there to maintain a level, a constant level in the degas return. That means that the outgoing flow is about the same as our incoming flow.